All right, so last time I told you how to read the table of standard normal distribution. So I handed out everyone this table, and for example, if you want the probability of the z value to be less than 0.67, and by the way, this in the slides I wrote it like this, which is the same thing. And the way you read it is like first go to 0.6 row, and then there's the 0.07 column. And if you see what number is located at where these two numbers meet, you see that that value is 0.74857. Is that right? Did I copy it correctly? 6, 7. Okay, yeah, looks good. All right. So that's how you read this. And you have to understand that the accompanying graph I frequently give you, the bell-shaped distribution, has the following meaning. See, here is 0.67. And if you look at the area before 0.67, this area right here, this area has the value of 0.74857. That's what it means. What this is really saying is this one. And because this interval starts from negative infinity up till 0.67, that's why sometimes I put that. But any number is bigger than negative infinity, right? So this is like, just to give you an idea that the interval that we're thinking of is this infinite interval, but it's more customary to just write this instead of that. Okay. All right. So having this idea, I said a few other things about this normal distribution, and some facts were that what's the area from negative infinity to positive infinity? What is the area? 1, right? So this entire area is 1 because this is what's called the probability mass function or probability distribution function, PDF. And a PDF has the property that the area under the curve corresponds to probability. And for a random variable that can take any value from negative infinity to infinity, if you ask what is the chance of that value being negative infinity to positive infinity, that's 1, right? That's everything, every possibility. So it should be 1. Okay, so that's 1. Another thing is that this one has center at 0 and it's symmetric. If it's symmetric, then what will be the area of this much?
0.5.
0.5, right? Yeah. Because it's symmetric, it'll be 0.5 here and 0.5 there. Okay. So knowing these information, I want to think about various other answers that can be answered, or various other questions I can ask, and see if you can answer them as I go along, right? So let's think about the following. A, what is the probability that you have 0 So what's the probability that the z value is between 0 to 0.67? Let's think about that. And it all starts by drawing the correct picture. Without the picture, it's hard to understand what's going on. Okay, so it's really important that you draw the correct picture. And here is 0.67. And here is 0. And the probability of the random variable z to be between 0 to 0.67 corresponds to the area between these two. But look, we already know the area from negative infinity until 0.67. What is that?
0.7.
Right. So this what I'm trying to say is that this thing right here, this much of the shaded area, is the same thing as taking the everything up till that point, the orange one, right? And then subtracting this half, right? And therefore, the area would be what? 0.74857 minus what? 0.5, right? Yeah. Because this area is 0.5. This much is this. This area is 0.5. And therefore, the answer would be 0.24857. Okay?
Can you explain that picture?
You want me to explain the picture again?
Like which one's which? It's kind of hard.
Okay, so you see that I painted this as orange.
Yeah.
The orange corresponds to the orange painted part.
Those two parts.
This, yeah, so this and this together is orange, right? Okay. Now, do you see that the one shaded only by black is this thing?
Yeah.
And indeed, if you take this orange part and take away this half, you just get this much. Do you agree? And that's exactly what I did. Is that good? All right. Okay, now let's think about the second question. What if I do probability of z between 0.67 to 1.09? Now, I want to give you some time to draw the picture and shade the area that corresponds to that probability, and think about what operations you must do in order to get that. This is a type of knowledge that you can only get it by doing it yourself. Okay? No matter how many times I try to explain it to you, unless you do it, you wouldn't be able to understand it. Okay, so it's very important that you do it. You have a question?
Yeah. So
Yes.
for the when it's like, so you figure out you get this part between those two, and then why do you include like so that equals that? So essentially you're getting that from subtracting it from what's less than 0.
So I guess your question is, how did I know to subtract those two?
And yeah.
Yeah. The problem is that in the table that we're given, the table always has the area from negative infinity to certain value. So if the question is, I want something that starts from 0 and ends at 0.67, then it's no good because that doesn't start from negative infinity.
Yeah.
So
for the next one, would you still have 0 in that same spot? Would 0 always be in the middle?
So yeah, okay. So I guess you're worried about the place of 0. 0 is here, and 0 is here.
So it's 0.5 because
This area would be 0.5 because of symmetry. The bell curve is symmetric, so half of it would be 0.5. And then, so as you can see, if you take this one and take out from this picture, this is all you get, right?
Yeah. So for the B, for like question B, you would still have 0 on the side, correct?
Yes.
It would just be to the right of the 0 would be that.
So these two numbers will be right side of 0.
Yeah.
All right, so I think I gave you ample time to think. Let's see if you got it.
I get some more time?
You need some more time?
Yes, please.
How many of you are almost done? Just 2, that 3, okay. Oh, you already got the answer. Yeah, I think that's right, yeah. Good.
I'm not sure what to do up to here. Me neither.
Okay, I think there are more people who are lost, so let's do it together, okay? So first draw the bell curve, and let's say this is 0.67 and this is 1.09, and I really don't have any idea where these numbers are exactly, but see, you just need to know which ones to subtract. So I'm not asking you to draw a perfect picture here. all we know is that here is 0, right? And these are positive numbers, so it must be on the right side, right?
Yes.
And we actually have two parts to this. One is, I know that this blue one, what's this value? What's this area?
0.8621.
1.09 is
No, 1.09 is here. What's the area of the blue shaded part? 0.86214, right? This value here is the area. This is the value of the random variable z, which follows this distribution, okay? All right, and then, now think about which one is the part that we want. We want this much, right? Right here. Okay? All right. But then, to the left of it, that's the orange part that I had here, right? So this orange part. So it looks a little complicated with all these three pictures, but here's the idea. You're really trying to get this area right here, the black shaded part. And that's really same as this one, where I shaded by blue. Okay. And then what's this number here? 1.09, right? Minus
everything before.
okay, what's this one? This one? 0.67, right? Okay. What are the actual areas though? So the first one is 0.86214, right?
yes.
And then minus 0.74857. Okay. All right, and then you have to do the calculation. It's 0. What is it? 1, 1, 3, what?
357.
357? Okay. So that will be the value. Yes?
What is Z? Like,
Okay, Z is some, so we're going to do some examples where we change a normally distributed data into the Z-score.
so Z is the Z score.
Z is what we call the Z-score.
Okay.
Z is a value that has the biggest chance of being close to 0, but then occasionally can have some huge values or small values. Okay? So think of it like you had like a bar and you hit it, right?
Yeah.
And a person who's trying to hit the 0 would usually get something close to 0, right? But then it will be off by a little bit, right? It's like some error, okay? And it has this standard deviation 1, so that it has this bell-shaped. And for that random variable, we're asking various questions about the area at this point, which is same as probability that you're going to see a little later when we link it to the actual real-life problems. Okay. Yes?
I thought the area of like the bell was 1, so how is there a 1.09?
Okay, so it's whenever you have, so the question was, you thought the area, the maximum area is 1, how can we have 1.09? See, whenever math becomes confusing, it's because you have more than one value that mean different things. Okay, so it's like you point to one thing, but you have to, like, there are two things and you have to know that, know which is which. So here, the shaded area are the probabilities, and the area under the entire curve is 1. Okay? Whereas the values here are the values that the z value can take, the z-score can take, and those can go to positive infinity or from negative infinity. Right? So there are two different things. Okay? So z-score can be more than 1, it could be 2, or it could be 3. Or it could even be negative, -1, -2, those are possible. But area can never be negative. It has to be at least 0. until the maximum value will be 1 because the entire area is 1. All right. Let's do the next one. Now think about the next question here. C, what's the probability that you can have z less than 0.67? Think about that. What's the probability that you can have z less than 0.67? Please draw the picture. And my recommendation is to draw the picture and then compare it with, oh, sorry, that is actually good. I meant bigger. Something was strange, okay. I meant bigger, okay. So please draw the picture and compare it with this one. Compare with this picture here. Draw the picture of this thing and compare it with this. See if you can make the connection. Yeah, I think somebody is onto the right way, right direction. Yeah. And actually, this will be a huge chunk of this entire class. If you do understand it, a lot of the things that we do will make sense. If you don't understand it, then this class will be really hard for you. Okay, so it's important that you draw the pictures, try to convince yourself what's going on. Okay? I do see that it's a challenge for a lot of students when I ask these questions.
Yep.
Okay, now let's start by asking yourself whether you drew the correct picture. Okay, so let's think about this picture. See, z score is the values at the x-axis. Okay, and here is 0.67, and you're saying that z score is above 0.67. So which way should you shade? To the right. And we're asking for this area. That's what this question is asking, right? Okay. Now compare that with this one here. This one. Well, I drew this but erased it, so let me draw it again. That's what it is, right? Okay. Who can tell me the relationship between those two areas? So this area, we know that it to be 0.74857. What's the relationship between this area with this area? Yes?
When it's added together, it equals 1?
Yes. They add up to 1 because if you cut this and paste it right here, they complete the area, which is 1, right? The entire thing becomes 1, right? So you can say that this must be 1 minus of this thing. Right? And I know that this area is given in the table. This 1 minus 0.74857, which is 0.25143. Okay. Yes.
Why would you? So, why is when you have the 1 minus and then you have the thing with 0.67, that like this picture you drew? Why is it to the left of the 6.7?
So to explain myself
You're
again.
trying to find if Z is larger, so wouldn't it be anything, like to the right of it?
This picture is described by this one.
Okay.
Z is larger than 0.67, so it's on the right side.
Okay.
All I'm saying is that I know that the entire thing is 1, right?
Okay.
So if I just want this, it's the same thing as taking the entire thing and subtracting this much. That's
Okay.
what this picture is saying.
Okay.
Okay? But I also know what this area is. That's given here.
Yeah.
So I subtract, and that's how you get the area.
Okay.
Okay? All right. Okay. Now, let's try Z less than negative 0.67.
Z is less than.
Did anyone get the answer?
Still working on it.
Yes.
We're getting there.
Negative.
No, the area can never be negative.
Is it 0.25 again?
I know I saw it. I've been using mine with engineering and stuff.
Right?
I just couldn't
It's
find it.
1 minus 2. Because it's negative, so you just switch.
Same number.
Okay, did anyone get the answer? Yes.
Is it 0.25, 1.3?
Yes. Yes. So you really got it. Okay.
Huh?
Yeah. So
You hear that? Yeah, I really got it.
here's a bell curve.
You want to do it?
Here's negative 0.67, and we're looking for this because Z is less than negative 0.67, so you have to be left of it, right? But then we know that the bell curve is symmetric, right? So this area should be actually same as this area here. But that area is what we got over here. Right? So those two areas must be equal because of symmetry. So the answer is 0.
So if it's less than
0.25143.
that's all that's left.
You know, when I give you time to do the work, it's totally fine to talk to one another, okay? If you're still clueless, that's actually very bad. You should be asking somebody sitting next to you how to do it, okay? You have a question?
Yeah, wait, I'm sorry. How did you get the 0.25?
I'm just copying this value from here. Because I know that this area is same as that one.
Oh,
And this area, I already got it as this one.
oh, okay.
Right? Okay, so probability of Z between negative 0.67 until 1.09.
I have a question.
Yes.
When you draw it, isn't it supposed to be like this way? You want less than?
No, I'm just saying that this is same as that, and this is done here. Okay, this value is here. We know. See, I know that this area is less than 0.5.
I'm just talking about like the shading part. How you drew the graph.
Yeah.
Part. Isn't negative? You want less than?
So I shaded this
Oh wait,
black.
never mind. I understand.
This one is not part of the drawing, okay? I'm just trying to make a point that this is same thing as this area right here. All right, make sure you either get this, or if you don't know, ask the person sitting next to you. It will be a very serious matter if you can't do this by now. Right? I expect everyone in this class to know how to solve this question. You can use all the facts that we've derived before. Okay, so you can use the answers from A, B, C, D, E, anything that you think is relevant. Okay.
Yeah.
Okay, what do you have?
Is it 0.86241 minus 0.25143?
Yeah, that's how you do it.
Great.
Good job.
Okay, so I'll send out the email again, but what we do today will be on the exam, the quiz. Of course it's on the exam, definitely, but this will be on the quiz, okay? You better learn how to do it. This is a threat.
It's not that hard.
We'll do it. Okay, so let's see. So first of all, you draw the picture, and your z variable is between negative 0.67 until 1.09. It's between these two values, right? Okay. Now think about some areas that you already know that's relevant to this. So for one, I know this area. Right? It's this one, right? 0.86214, right? And then from here, if I can take away this much, I get the black shaded area, don't you think? Right? Okay. So we just have to take this much and take away. But what is this area? Just did it. It's this one, right? So you can say that this must be this minus. So this will be 1.09 here, and this will be 0.67, negative 0.67. And the answer is 0.86214 minus 0.25143. Did anyone calculate this with a calculator?
Yes.
What do you get?
6,107.
0.61071. Okay, so that's the answer. All right, so I really had to make sure that everyone understood this because now we'll.
Professor?
Yes.
Wait, but that doesn't make any sense because I thought, so didn't we say that the area of the value between like 1 and 0.67 was 0.25143, right? And then if we subtract that value from 1, that gets us 0.74857. Correct? And then we have to like multiply that area by 2.
Oh, okay. I think you're probably saying the following. You have. So according to what I hear, I think you did 1 minus 0.25143, which will be this area, right?
Oh, so that would have gotten me the area from like, so if we think about it, isn't it like we have 0 in the middle and then 1 and negative
0
1?
is here, right?
Right. So then if you do like, yeah, so if you have like an imaginary like negative 1 all the way to the left, right? Yeah, you do like 1 minus that value. That's
No, don't think about 1 here on the as a vertical line because that's not the area here. This one is not the value 1. This one is the entire area 1. Okay, there are two. As I said, there are two numbers that's involved here. That the values across the x, which is the z value, and the area. Don't confuse the two. Once you start confusing the two, nothing will make sense. Right? Yes.
If there's a negative number, you should just do the area of 1 minus whatever that number is, and then once you get that number, you subtract.
Okay, so all right, there are several things that I end up having to explain. So good. So the question I just got was that if you have z less than negative alpha, is this same thing as 1 minus p of z less than alpha? And that is indeed correct. Okay.
So
This
every
is-
time you have a negative, you do that.
You can always use this formula But that's something that you figured out, right? If you figured out, that's great. You can use it. I don't recommend you to memorize this formula and use it because that's like trying to solve it without really understanding the picture. Okay? If you understand the picture, you immediately see why this is true. Okay? And that's easy, right? Okay. And then another comment I wanted to make from here is that I said it like this, but there are actually a lot of different ways you can get the same answer. So one way would be to do this. If you subtract 1 minus 0.25143, this will be this area. And from here, you can get rid of this one. Well, how do you get rid of that one? That will be, this area here will be 1 minus 0.86214. So you can take this one and subtract this, and you get the same answer. So that will be 1. It's just like cut and pasting different parts to make it. So there are several different ways to get the same thing. So you can also do the following. Here's a completely different method. You can divide this area into 2. And first think about this area. What would this area be? How would you get this one?
1.09 minus 1/2.
Yeah. 0.86214 minus 0.5 will be this area, right? And then you can also get this area because by symmetry, this much, the same thing as this area, which we did in part A. Okay? This area is same as that one, which would be this one minus 0.5. You calculate them separately and add them, you get the same answer. Right? So there are many different ways to get the same thing. And if you understand how these areas can be pasted together, or if you can see the symmetry and how the half is 0.0 and afterwards is 0.5. If you understand the picture, then all of these will be just straightforward. Okay? All right. Now let's try to apply this to an actual random variable problem. So here's a question. U.S. male height. U.S. male adult's height has the mean value equals to 70 inches and standard deviation 3 inches. Okay? Now, if you pick a random person in the street, or let's say if your friend set you up on a blind date and you went to meet that guy, right? Then you can ask, what's the probability that that person's height is more or equal to 6 feet? So 6 feet in inches is what? 72? Right, 72. So that's the question. Let's think about that. So height is an example where it follows a bell curve. And when you say that the male height has the average 70 and standard deviation 3, that means here's 73, here's 67. And you remember the 68, 95, 99.7 principle, right? So it means that 68% of males have height between 67 to 73. That's what it means. Okay? Now, perhaps in a different country, you might have a bigger standard deviation. That means that the bell curve shape was more spread apart. If you have another country with smaller standard deviation, then the bell curve is like tighter. That's what it means. But that this is the way we can understand the picture. Yes, you have a question?
Yeah, so essentially the U thing is the whatever's in the middle.
So right.
And
So
then
this alphabet, this is a Greek alphabet for M. And that's for mean value.
Okay.
Mean is the average.
And then the
Average
other one-
height is
And
this.
the other one's standard deviation.
This one is the Greek alphabet for S.
Mhm.
It's for standard deviation.
Okay.
Okay?
And then you do
It's
the-
about how much is spread apart.
Okay.
All right. Now, the problem is that here, if we shade what we want to know, is exactly this. I have this 72 somewhere here, and I want to know the probability of this. The entire area is 1, and what's the probability of meeting a random guy and is 6 feet or above? Okay? That's the question. And the way you get it is the following. Because this is not so well known, we transform this picture into the picture of z-scores. So you remember what the formula for z-score was? Z-score was x minus mu divided by the standard deviation. Right? So if I do that to the 72, here's what z-score for 72 is. We take 72, subtract 70, divided by 3. Okay? And that gives you 2/3, which is 0.667. Or 6667. It's 6 repeating, but let's just say that. Okay? Okay. So, in terms of the z-score, which is now centered at 0, see, subtracting the mean value centers this picture. It shifts everything by 70 so that now it's centered at 0. And dividing by 3 makes it closer so that this standard deviation is standardized. It's 1. Okay? So now you have the z-score, and here is 0.667. And we're trying to find this area. Now, unfortunately, our table doesn't have the value for 667, so we'll have to round it to the nearest, which is 67, okay? So what is this? What is this area? We just did it, right? This area is probability that the z-score would be bigger or equal to 0.67. And that happens to be the one that we just did. Okay. Now, by the way, because this is a continuous random variable, having an equal sign or not, it doesn't matter. Because, excluding the equal sign just means that you're replacing this line with the dotted line. And taking a line away from the area doesn't change the area. It's like a line has 0 area, right? So it doesn't matter whether you have inclusion or not, okay? So we can just quote this one, which is 0.25143. So the answer is there is about 25% chance that the guy that you meet is going to be 6 feet or above, right? So that's how it works. Okay, you know what? I should probably write it like this. P z bigger or equal to 0.67 equal to 0.251. Okay, any questions? All right. Now let me ask a similar question.
Professor,
Yes?
that formula, is that something we gotta memorize or will it be provided?
The z-score, we're going to be using this so much that you should memorize it. Okay? But you should also think of it like what you're doing is you're normalizing this bell curve shape. So you're shifting so that the average is now 0, and then you divide by sigma so that it has this standard deviation as 1.
Then we use x minus x total over standard deviation.
No, that's not. That's for the sample. We'll do that later. Yes.
How do you identify the x? Like I know like.
This is the value for x, right?
Like standard deviations like that.
So you subtract. All right. what I'm just doing is I'm taking this value and transforming it into this value by using the z-score. Then the condition for x just becomes the condition for z.
So like, for an example for a question, you would originally have like the stuff we have on the other page, like p, probability of z is less than 0.67, and you would give us that.
So the question is, how do we get this? Well, you will have to use this table,
Use the z-score table.
and then you have to do this calculation, 1 minus that.
Okay, and then
Okay,
that's
so
how you
that
figure-
part is like, I'm just using the old one, but you have to do that if this was given without that part.
Okay.
Okay. All right, so I think you still want to see how this transforms to that. So I'm going to give you a mathematical explanation of how this changes to that. But and if it does click, that's great. Okay, but it's a little bit technical, so that if you don't understand it, then just accept what's on the board. Okay, so let me try this. What I can do is I can take x. First, I can subtract mu both sides, right? And the inequality is still the same, right? If you subtract average both sides, the inequality is still the same, right? Now I can divide by any positive number, then the inequality is still the same. Do you agree? But then what is this? This is what we call the z-score, right? So this now changes into z. And then mu is 70, so 72 minus 70, that's 2, and sigma is 3. So that's what you get. And I just rewrote this as 0.67. That's what happened. That's the purely mathematical explanation of how to go from here to there. Okay. Now, if that worked, how many of you understood this? Oh, wow. Okay, a lot more than I thought. Okay, that's a more technical way to do it. But if you didn't understand that, that's fine. All you have to do is just whatever inequality you have and you see a number, just take the z-score and just put it right there and change from x to z. That's all you're doing. That's still fine too, right? Okay. So let me give you this next question. What's the probability that x is between, say, 5'10" to 6 feet? 5'10", what is that? 70? Yeah, right. So 70. Oh. Give me that. So again, the way you do it is just take the z-score of this, and rewrite as, put z as between these two numbers. That's all you're doing, okay? Okay, I'm actually running out of time, so I would love to give you more time, but I'll have to do this, okay? So what we do, we first take the z-scores. Z equals to 70 minus 70 divided by 3, which is 0. So this one corresponds to 0. Z equals to 72 minus 70 over 3. That's 2/3. So that one corresponds to 2/3. So that means this is the probability of z between 0.67 and 0. Okay? Yes?
You're getting the 0.67 from 2/3 by just rounding.
Yeah. So this is really 0.66666, like that. And then our table only has 0.67, so I'm just using the nearest.
Should we bring the table for the?
In the exam, you'll be provided with the table.
Okay.
You can also use your calculator to get the same thing.
What about for the quiz?
Hmm?
Since you said this is going to be on the quiz, can we use the?
Oh, for the quiz, you will also be given the table.
Okay.
All right. So what is this? Well, we know that 0.67 was what? This was 74857. 74857. 67. Okay. But then that will be from negative infinity to 0.67. But since you're starting from 0, you have to subtract something. What do you subtract? 0.5. And therefore, this will be 0.24857. Okay. Now the z-score actually gives you some idea of the distribution in various sense. So let me pose a second question that you can try. The SAT scores. I don't know which year this was, but the mean value is 1,060, and the standard deviation is 195. And question is, what percent of students get 1170 and above? Okay. Suppose you had such a question. How would you answer that? Yes.
Question, when you write out the answer, do we have to put like the P and all that stuff, or what if we just put the like numbers?
Okay, so in the exams and quizzes for these, you will be asked to always draw this bell curve and shade the area. So you have to be able to shade the correct area. And also you have to show that you can calculate the z-score. These are the things that I'll be looking for. If you don't have that, then you wouldn't receive full credit. Thank you for that question. Right. So here's what we can do. First, what are we trying to do? We're trying to find a percentage of people that has 1170 or above, right? That's the question, 1170. Huh? Okay, thank you. Yeah. So now you have to translate this 1170 into the z-score, and 1170 minus 1060, the mean value, and divided by the standard deviation. Let's see what that is. 1170 minus 1060, enter, and then you divide that by 190, and I get
195. 195.
Oh, 195. Okay, sorry. 1170 minus 1060, and then divide by 195. You get 0.5641. And because our table only has this much, we'll round it to the nearest two digits, 0.56. And therefore, this translates into P. So what we do is first take the z-score, replace the value that you see. So this value is now changed to that. Inequality stays exactly the same, and x gets replaced by z. So this percentage is same as this percentage. And now let's look at the table. 0.56. Let's look at the 0.56. So 0 and then 0.56 is this area right here. 0.56, I have 0.71226. So this is 0.71226. Okay. However, can you shade this area?
1 minus.
It should be 1 minus, right? Because here's 0.56, and we were looking at how many people get above, right? So it'll be the right side. So what do? You take this, and you do 1 minus 0.71226, and that is 0.28774. And so 28.787%. Okay. About 29% of people, or 29% of students, score 1170 or higher. Okay. Yes.
It's always 1 minus, right?
No.
What did you say?
It's 1 minus just because the shaded area is right here, and the table is always this one. Okay. So what's always is that when you read the table, the value is always shaded on the left side in this table that we're given. Okay. And to convert this to that, we have to do 1 minus. All right. Okay. Now, here's the second question, which is slightly different from what we've done so far. So here's the second question. What is Q3 of SAT? Okay, so let's think about this question. What's the third quartile? What is the third quartile? What does that mean? Yes?
0.75.
It's 75% from what? From above or below?
Above.
So from below, it's like what you're saying is that this much is 75%, and this it's asking for this value here. Okay, that's Q3. This value is Q3. So now you see that the question is slightly altered. Instead, so far, the question was always that I give you the number, and you have to tell me the area, right? But now, the area is given. If you convert it to an area, this is 0.75. So with this given area, what is this number? That's the question. Does it make sense? Okay. Now, how can we answer this? Well, go back to the table. Now we're doing reverse searching. So you're going to look at this and look for 0.75. So I look for 0.75, and unfortunately, here's what I get. I get P of Z less than, what is it? That's 0.67 is 0.7487, and P of Z less than, it doesn't matter if you have equal or not, 0.68 gives you 0.75175. Okay. So, which one's closer?
0.68.
That's like one. Oh, okay. So actually, this is closer. This is closer to 0.75, right? So we're going to take this one because this is closer to 0.75 than this one. Okay. So we're going to take 0.67. But that's the z-score, right? Now what you have to do is you have to convert that into the x-score. So what's the relationship between x and z? Z is x minus mu over sigma, and in this context, z is x minus 1060 divided by 195. Right? And then because z is 0.67, we plug that in here. We plug in 0.67 for z, and now we end up with an equation for x. So you multiply this and then on here you'll have to get rid of the 1060 by adding 1060 both sides, right? So that they cancel. And that's your value, which you can use your calculator for. So let me use your calculator again. So you have 195 times 0.67 plus 1060, enter. And that's 1190.65. So rounding it to the nearest integer, it's 1191. So the answer would be x equals to 1191. So that's the third quartile. Right? So if you want to be inside top 25% of the students, this is the SAT score that you should be getting. You have a question?
Yeah, how did you like know to do 0.67 or 0.68?
So, you know, when I'm grading, I wouldn't really like make it a big deal if you chose this one. But if you see, our target is 0.75, right? And if you do 0.75 minus this one and 0.75 minus this one, you get the value of 0.00175 versus this would be 0.00143. So 0.00143 is less than 0.00175, so I determined that this is. Yeah, another way that some people might want you to do would be to take the average of this, because it's like in the middle. So that will be another good one, right? Okay, so sorry, we're a little behind, so let me just end with the last topic, which is really brief. Okay. So confidence level. Okay, so we have been working with this bell curve a lot, and often what we want to do is to see what percentage is between what and what. So the confidence level called okay, so the confidence level, I forgot which one we use. Alpha is a significance level. Confidence level. Oh, P. Okay, so I guess you use P. All right, so this P value where you have this is so in general you can get a question that looks like the following. I provide you with P for a z-score, and you have to tell me that what is the z value where negative z to z has that exact value. So I'll just end with this question. So if for confidence level 0.04, no, 0.94, find z alpha over 2. So this means that what is the interval that will account for the 94% of the case? And you end up with this kind of question when you're planning and you want to make sure that you can serve the 94% of the customers or 94% of the things manufactured and something like that. Okay? So in that case, what you do is you first take 0.94 and you get the alpha value as alpha would be always 1 minus 0.94. So alpha is 1 minus P, where P is the confidence level. And what this gives you is the following area, this area, right? And then alpha divided by 2 is, this is 0.06, so you divide this by 2, so it's 0.03. And what you want is that you want this area to be 0.03. And the question is, what's z alpha over 2? That's the question. So how would you get that? Well, now think about the following. If this is 0.03, what is this area right here? 0.97, right? So to get this z alpha over 2, what do? You look at the table. Let me borrow this. Is this fine? Okay. So you look for 0.97. Where is that? 0.97. Yeah. So that's 1.88. So right now 1.88 gives you a value very close to 0.97. Okay. So the answer is 1.88. That's how you do it. All right, so next, on Wednesday, we will do a little bit more about this, and I'll also show you how to do it using a calculator.
Now I'm like, yo.